In coming up with a piecewise function for the graph, this can be kind of tricky if you're not careful, but it can be very simple as long as you know what to look for. The first thing you're going to look for is, number one, the first piece is a line. Now, what do you need to know to come up with the equation of a line? Well, you need to know the slope, and you need to know a point on the slope, or you can, if you can, extend it to get the y-intercept. So if you can get the slope and the y-intercept, then certainly you can come up with y equals mx plus b, and then you have to find the domain restrictions as well. Well, clearly we can see the domain restrictions for the first piece are x values less than -1. So x has to be less than -1, not less than or equal to, because of the open circle. The second piece, might as well talk about that. The second piece, again, linear, second piece, and that's also a line, so we're just going to come up with the equation of a line. And by looking at the line, you can see that the x values are greater than or equal to 1. And so we at least have the domain restrictions. And then all you have to do, again, is figure out, well, what's the slope? And the slope of the first piece would be up 1 and over 1. Just find 2 points on the line and find the slope. So slope is 1. Now, if you extended the line, it would have a y-intercept of 0. So you can do that. You can figure out what the y-intercept is just by observing the line. I'll show you another way to do that in a second. But if we replace m with 1, and the b with 0, basically we get y equals x. So this line is the line y equals x, and so f of x equals x. That would represent the first piece of the piecewise function. You always do the one on the left first. And let's do the second piece, and I'll show you a different way to do this if the slope or the y-intercept is unclear. Oh, so this one actually it would be a little bit unclear, because here we see the slope is up 1 and over 2, up 1 and over 2, so the slope is 1/2. And then if we extended it, it's not going to hit the y-axis at a nice point for us. But we could guess, but we don't want to guess. So let's show how to do this a different way. If we know the slope and we know a point, then let's say we use the point 1, 2. Well, we know how to find the equation of a line when we know the slope and a point. We know that we do y minus y1 equals slope times x minus x1. And then we replace y1 with 2, the slope with 1/2, and the x1 with 1. And then we're going to multiply that. We're going to distribute the 1/2, and we get y minus 2 equals 1/2 x minus 1/2. And if we add 2 to both sides, so here's the deal. You have to solve for y and then put what you get for y right in there in that second piece. That's why we're solving for y. We get y equals 1/2 x. Now, minus 1/2 plus 2, we'll do that here, and then we'll do that one last step. So minus 2 means we have to get a common denominator. 1/2 plus 2 is 4/2. So when we get a common denominator, we combine these two fractions, and we get -1/2 plus 4/2, which is plus 3/2. And so this is the y equals 1/2 x plus 3/2 is the second piece. That's the equation of that line, but we only use the equation of that line, 1/2 x plus 3/2. That piece is the piece that we use when the x values are greater than or equal to 1. So that's probably one of the toughest piecewise functions that you'll have to come up with, because of the fractions in there. It's not clear where it crosses the y-axis. So you have to do a little bit more work when it's not clear where it's going to cross the y-axis, where it's not clear, it doesn't hit one of the integers along the y-axis, and so you can't just extend it like we did the first one. So that's it.